So how does this happen? More accurately, how does this continue to happen? I remember as a kid in the 1970s seeing Senator William Proxmire describe waste such as this as he gave his Golden Fleece Awards, and here we are 40 years later, still with the same kind of questions. Part of the problem is the old adage, publish or perish. Researchers that publish are more likely to get federal funding, and unique research is more publishable. So how do unique projects get funded to begin with? At some agencies, grant applicants themselves can actually recommend who should review and make the recommendations on their grant. So the people getting the money can recommend who approves giving them the money. That's right, researchers get to pick the people who approve their funding. Doesn't sound very objective. Some grantsmanship books advise applicants to recommend reviewers who will be champions for your work, while agency guidelines suggest disqualifying those who have scientific disagreement with you. So we teach people how to get grants, and we say, find people who agree with you and get them on the committee. If you know anyone already disagrees with you, make sure you keep them off the committee. This is baking in bias, and it's unacceptable. So I've introduced legislation that will prohibit this practice and further require impartiality on grant review panels. Another problem we've found is downstream funding, or taking original grant money and giving it to other researchers for projects that are often not consistent with the original grant. The federal government gives someone money to do research. That person then gives it to someone else, who even may give it to a third or a fourth party. None of this is published in public government databases. One example of this problem was a study that its intent was to what makes for the perfect first date. Now, to me, the problem is the original study to begin with, not the fact that we're subcontracting, but this is the title of the study, What Makes for a Perfect First Date? The original grant to study how scientists collaborate on scientific research. So they were going to study collaboration on scientific research. They somehow got to what makes for a perfect first date. It's difficult to discover how much of these studies cost because they're cobbled together from multiple subgrants. So my bill would curtail this by requiring that all subgrants, no matter how removed from the original grant, be fully reported, approved, and made public. We also found that many grants are issued for rational but broad research subjects and then are used for ridiculous ancillary projects. For example, one researcher took money from NIH to study drug and alcohol abuse and then published a paper on how to select the best wines for your palate. I'm not sure how this prevents alcoholism, but I'm pretty sure it must have been interesting to the journal editors. So our bill creates a special inspector general to oversee this and make sure that we're spending our money wisely. Why should we do this? Well, we spend $700 billion more than we take in every year, and we have a $20 trillion debt. It is inexcusable just to keep shoveling good money after bad without paying attention to how we spend it. We've also have asked in our bill for something called a taxpayer advocate for research that can look into these matters, provide rigorous oversight, and report to Congress about such follies. Our bill also requires that committees reviewing grants have at least one researcher from a scientific field unrelated to the subject area to further remove personal bias. The idea is to have a scientist from important areas of research, such as cancer, diabetes, Alzheimer's, heart disease, sit in on review committees that would review grants for wine tasting. Maybe someone would say, you know what? We really have a lot of people with Alzheimer's, or we really have a lot of people with heart disease. Maybe someone would say, maybe the shrimp on a treadmill is not something we have to study, or maybe the money could be better spent somewhere else. The last problem I'll discuss is replicability. An increasing body of work shows that in an effort to publish, a lot of research is not reproducible. This means that the study cannot be duplicated by other scientists to produce statistically similar results. That's a major problem, and it goes back to this issue of publishing. Journal readers and editors don't get excited about negative results, so the bias is towards funding studies that prove a premise versus studies that may disprove a premise. My bill would seek to address this by creating greater transparency through the whole process so taxpayers can know exactly how their money is being used. This will allow the scientific community and the public at large to be able to collectively review and evaluate taxpayer-funded research. Hopefully, this will deter study manipulation to prove hypothesis. Some will say that the general public doesn't understand science, But I don't think you need a PhD to understand people are less likely to choose food that has been sneezed on. And they don't want that kind of research either. With that, I'd like to recognize our ranking member, Senator Peters, for his opening statement.
Well, thank you, Chairman Paul, for holding this hearing today. And I'd like to join Chairman Paul in thanking our witnesses for taking the time to be with us here today. I look forward to hearing your testimony. One of the essential tasks of this subcommittee is to engage in honest evaluations of the public investments that we make as a nation and whether or not these investments are indeed worthwhile. This is a responsibility to the taxpayer that I personally take very seriously, and I'm grateful to have an opportunity to do so in a collaborative, bipartisan way. We are here today to discuss federal funding for scientific research, which I believe remains a necessary investment in our collective future. Scientific research is the seed corn of innovation and new discoveries, and federal investments in research and development have led to discoveries that have had profound impacts on public health, safety, and our quality of life. Federally funded research has resulted in widespread adoption of technologies as revolutionary as the Internet, GPS satellites, MRI imaging, and the Human Genome Project. This research results in economic growth in every state and leads to the creation of tens of thousands of jobs in entirely new sectors of the economy. It inspires the next generation of Americans to believe that the sky is the limit and that no challenge is impossible. Even as the share of federal investment remains at a historic low as a percentage of overall gross domestic product, supporting federally funded research remains as important as ever to maintain America's competitive edge in an increasingly competitive global economy. Targeted federal investments in research can accelerate, catalyze, and encourage private sector innovation that may not have otherwise occurred. We should recognize that the federal and private contributions to the research and development enterprise are not perfect substitutes for one another, but instead work in tandem with each other, focusing on different stages in the R&D cycle. Last year, I was proud to introduce bipartisan legislation with Senators Gardner, Thune, and Nelson, known as the American Innovation and Competitiveness Act, which was signed into law in January of this year. The bill was the product of a year-long effort that began with a series of roundtable discussions with representatives from science, from education, business, and economic development communities on how to improve the American research and innovation ecosystem. Our legislation reauthorized a number of important programs that promote research and scientific inquiry, strengthen innovation and advanced manufacturing, grow our skilled workforce, and enhance American competitiveness around the world. The bill included a number of provisions that aim to reduce regulatory and administrative burdens on academic researchers so that they can spend more of their time on research and less on paperwork. Our bill also reaffirmed the independent merit review process that guides NSF funding decisions and ensures that research proposals are judged independently on the merits by peers in the scientific community and without bias. While certain basic research projects that receive federal funding certainly have some very silly-sounding titles, further examination may reveal the true scientific merit and potential broader impacts of that work. Before a proposal gets 1 penny of funding, reviewers have to consider it based on criteria that include whether the proposal increases economic competitiveness, advances public health and welfare, or supports the national defense. It's worth noting that only 1 in 5 proposals receive NSF funding at all, and that NSF is required to justify to the public why these proposals were lucky enough to receive funding. Even as research begins with a clear question in mind, it can be hard to quantify or predict exactly where the science will lead. Rather than inject politics into this process, our discussion today should instead concentrate on how to safeguard the often unexpected process of discovery inherent in scientific inquiry, while ensuring that federal dollars spent on research remains completely and fully accountable to taxpayers. Part of the solution may lie in breaking down barriers rather than remain ensconced in the ivory tower of academia. Scientists should be prepared to engage in a robust exchange of information with the general public about the goals and benefits of their research. The discussion we're having today is an important one. Our country faces critical environmental, public health, and economic challenges in the years ahead, but we must not shy away from them head-on and leveraging the power of our research enterprise to create a better tomorrow for each and every one. Thank you again for our witnesses for your time today. I look forward to the discussion.
Thank you, Senator Peters. With that, I will begin by introducing our first witness, Brian Nozick. Dr. Nozick is the co-founder and executive director of the Center for Open Science at the University of Virginia, which works to increase the openness, integrity, and reproducibility of scholarly research. Dr. Nozick holds a PhD from Yale and is professor of psychology at the University of Virginia. We're happy to have you here and to get your thoughts on these critical issues. Dr. Nozick.
Chairman Paul, Ranking Member Peters, members of the subcommittee, on behalf of myself and the Center for Open Science, thank you for the opportunity to discuss the funding of scientific research and the role of transparency and reproducibility to maximize the return on those investments. Science may be humanity's most important long-term investment. The effort to accumulate knowledge has profound consequences for growing the economy, security, and well-being of American society. Some of the impact of scientific investments are directly anticipated in the project aims, but much of the impact is indirect. Research often leads to unexpected insights and applications that are only appreciated after the discovery. And these unexpected directions can produce returns that are many orders of magnitude larger than the original investment. Simultaneously, there are opportunities to nudge the culture of incentives in science to be even better stewards of taxpayer support. In 2002, I became a professor at the University of Virginia in the Department of Psychology. My group does fundamental research on implicit social cognition, thoughts and feelings that occur outside of conscious awareness or conscious control. And my lab has had federal support from NIH and NSF. Since 2013, I've been on extended leave from the university because a graduate student and I spun out a technology and culture change company from my lab called the Center for Open Science. The center has a mission to increase openness, integrity, and reproducibility of research and has received support from NIH, NSF, DARPA, and IARPA. Transparency and reproducibility are core values of science because they're how science advances knowledge. When I make a claim, you could believe it based on my authority as an expert or how confident I seem making it, but these are not sufficient for scientific claims. For credibility of scientific claims, I need to show you how I arrived at the claim. By showing you my methodology, the data I collected, and how I analyzed and interpreted that data, you can make an independent assessment. You might recognize a flaw, think of an alternative interpretation, or have an idea about how to extend what I did to learn more. Moreover, by sharing how I arrived at that claim, I give you the opportunity to reproduce the evidence. If you can independently obtain similar results, then our confidence in the claim increases. The challenge and the reason for the Center for Open Science's existence is that the culture of incentives for scientists sometimes undercuts the core values of transparency and reproducibility. The culture rewards novel, positive, clean results, and there are few incentives for being open or reproducible. As a consequence, we may be producing exciting results at the cost of credibility of those results. And some evidence suggests that the reproducibility of the published literature is lower than desirable or expected. Federal research funding agencies are aware of this problem and only have taken initial steps to address it. This can change. If transparency and reproducibility are incorporated into the policies and incentives shaping researchers' behavior, we may reduce waste and increase the pace and efficiency of discovery and ultimately even greater returns on investment of taxpayer dollars. I will close with a specific suggestion that the committee could pursue to help further the efficiency in scientific research, and that is to set the default to open for papers, data, and materials. In 2013, federal agencies were asked by the White House to make a plan for improving the management and accessibility of data and materials for the research that they fund. Most agencies have completed this work. Congress could take the next logical step and require each federal research funding agency to develop policies that require the research data and materials generated by federal dollars to be made publicly accessible by default upon the publication of the findings or completion of the grant period. Changing the default from closed to open would alter cultural expectations and behavior. Instead of needing to generate reasons to share data, researchers would need to provide justification for delay or to not share at all due to proprietary or privacy concerns. Public investment in science leads to solutions, cures, and entirely unexpected advancements that benefit American society. Changing the default to open for scientific research data would transform science, dramatically increase the ROI from publicly funded research, and accelerate progress. This is not a difficult proposition in concept, but it does require a mandate. This one action would dramatically increase the public benefit from our investments in science. Thank you, members of the committee, for your continuing support of science and for the opportunity to speak to you today.
Thank you, Dr. Nozick. Our next witness is Terrence Keeley. He's a senior research fellow at Cato Institute. Prior to joining Cato in 2014, he served as president of the University of Buckingham, the only university in Britain to be financially independent from the government. He has also lectured in clinical biochemistry at the University of Cambridge and is the author of The Economic Laws of Scientific Research. Dr. Keeley holds an MD from the University of London and a PhD in metabolic chemistry from Oxford. During his laboratory career, he focused on the study of inflammatory skin conditions. Thank you for being here, and we look forward to your opening statement.
Thank you very much for having invited me. And I'm very glad to be speaking after Dr. Nozick because, in a sense, my 5 minutes is about addressing how we got to a situation where Brian Nozick's research became so important. In my testimony, I provide the evidence, and with great respect to Senator Peters, I have to say that there is, I'm afraid, simply no evidence that economic growth or technological growth that leads into economic growth is in any way benefited by the federal funding of science. It is widely believed that governments should fund science. It's based on a model of what science is that I regret is unscientific. And in my testimony, I hope I've shown pretty clearly that the government in this country and no other government needs to fund science, at least for economic reasons. Nonetheless, I'm going to take the testimony as read. I'm not going to revisit it. I'm just going to accept that that's what governments do. They fund science. And what they do in consequence is they impose a particular model on science, which is called the linear model, which is actually has a history of 400 years. It was first prescribed by Francis Bacon 400 years ago in England. And the model says, very much as Senator Peters suggested and very much as Dr. Nozick suggested, that what you need is you need a group of scientists doing pure research in universities and similar research institutions where they are free to follow their own curiosity and to follow where the science takes them. And then as a consequence of that, knowledge leaks out to the rest of the world and is then turned into technological and other forms of sociological advance. That is not how science happens in the free market. In the market, scientists who are embedded within companies and industry are embedded very tightly with technologists, with other members of the company, even with marketing. They are part of a commercial enterprise. The result, therefore, is that there are two ways of judging scientists. And in industry, scientists are ultimately judged by their technology. How does a scientist's research ultimately lead to technology that is of benefit, of course, immediately to the company and to the stockholders, but to society at large that way? As Daniel Sarevitz of the University of Arizona said in a very influential essay last year, it's technology that keeps science honest. But the government funding of science makes scientists answerable not to technology, not to stockholders, but to fellow scientists. And that leads directly to the two problems that Senator Paul indicated. First, the problem with peer review is that you end up with a group of people all agreeing with each other on which particular paradigm they wish to support, and often unconsciously, scientists are profoundly honest people, but nonetheless they have their own interests, and unconsciously supporting paradigms that, if they were tested against the technological market, would never have survived for nearly as long as they do survive in the academic world. Such an example might be the 40-year history of governments telling us not to eat fat, which was based on a group of scientists telling another group of scientists that they shouldn't eat fat, and all agreeing with each other. It was, of course, wrong. But the other problem, again, as Dr. Nosek and the Senator Paul indicated, is that scientists are not judged by what they achieve, they're judged by the numbers of papers they publish, at least in part, and they're judged by which journals they're published in. So to be savage about this, scientists are not judged by what they achieve, they're judged by what they write. And the consequence of that is that scientists are encouraged to do the sort of things that Brian Nosek has picked up, such as produce papers that are not easily reproduced. And the reason they produce such papers is the benchmark for success is having the paper accepted, not making an important advance for humanity. So to conclude, this country has engaged since 1950, when the NSF was created, in an interesting experiment of the federal government funding science. It's had no impact on fundamental rates of economic growth. What it has done, it has created a microclimate or a niche where scientific pathologies have proliferated. And the answer, actually, is to question anew whether governments should be funding science at all. Thank you.
Well, I have the great pleasure to introduce a fellow Michigander, Dr. Rebecca Cunningham, who is representing not only the state of Michigan, but a great American university, the University of Michigan. Of course, we are blessed with a number of great universities in our state, but it's great to have Dr. Cunningham here. She is the Associate Vice President for Health Sciences Research for the university, professor for the University of Michigan's Department of Emergency Medicine, and a professor in health behavior and health education at the U of M School of Public Health. Dr. Cunningham has a very distinguished career in conducting clinical trials focused on public health interventions in health settings such as the emergency department. Her past clinical trials have focused on interventions in the emergency room using technology to overcome barriers to reaching youth to prevent alcohol and prescription opioid misuse. This is a matter, of course, of great interest to this committee, and I applaud all of your efforts in that area. Her federally funded research over the last 18 years has focused on improving the health of children and young adults and those seeking emergency health services. Also notably, Dr. Cunningham started her career as an attending physician at Hurley Hospital in Flint, Michigan. Thank you, Dr. Cunningham, for your service, and thank you for testifying here today and representing us all very well.
Thank you for that introduction. Good afternoon, Chairman Paul, Ranking Member Peters, and members of the subcommittee. Thank you for inviting me to speak with you today about the value of federally funded research. I also want to give special thanks to Ranking Member Peters for his work on crafting and securing the passage of the American Innovation and Competitiveness Act, which serves to support the critical federal research enterprise that I am here to talk with you about today. Our great nation is what it is today because of the federal investments in research. We are leaders in innovation because of these investments. Our economy is strong because of these investments, and our top research institutions are the envy of the world because of these investments. This investment has supported and must continue to support basic, curiosity-driven research alongside applied research and engineering. The knowledge that we derive from fundamental research is the seed to innovations like self-driving cars and life-saving drugs. Another example is the iPad. Without federal research investments to deepen our understanding of basic scientific principles across many agencies, engineers never would have been able to design the core software and components that make the iPad such a groundbreaking device. This is just one example of the possibilities that come out of fundamental research, innovations that our imaginations cannot always comprehend. I have seen the benefits of these innovations firsthand. As an emergency physician, I have seen the success of drugs and new medical technologies that allow patients to walk out of the hospital today who would have died while I was a medical student. I've sat with the spouses, parents, and children of those who have fallen victim to the epidemic of opioid overdose in our nation. Over the past 20 years, funded by the NIH and CDC, I and our research team and lab have worked to develop interventions for the treatment of children impacted by substance abuse or trauma who flood our emergency rooms. And such research has prevented many more from needing our care. For example, I am partnering with scientists and community leaders to address the opioid epidemic that is impacting every community across our nation. Translating the underlying science of opioids into policy solution relies on fundamental research, from synthetic chemistry funded by the NSF to basic neuroscience funded by the NIH. Policies based on sound fundamental science and life-saving medical breakthroughs will ultimately lead to the solutions that we can't yet imagine but need for the opioid crisis. Federal support for research has been part of our country's fabric dating back to the start of the Republic in the 1700s. In the past 70 years alone, the role of funding in game-changing interventions has been tremendous. For example, the development of the GPS, supercomputing, the visible LED, the technology behind the MRI machine that aids many of my patients in diagnosis of brain disease, all have their roots in federal investments in public sector researchers. Federal investments in research also help drive our economy and train our future STEM workforce. At the University of Michigan, there were 444 new inventions last year, and 12 startup companies launched based on technologies developed by our researchers. Federally funded research supports local economies all across the nation by providing billions of dollars each year to vendors, from small businesses to biotech companies who are making devices, software, and other equipment needed to perform our research. In the past 15 years, vendor spending to support research at the University of Michigan has created 221,000 manufacturing jobs and 641,000 healthcare jobs. This investment also supports thousands of employees working in laboratories and research institutions across the country, many of whom the largest recipients by far are our students. It is this next generation of students that will drive and support American innovation and competitiveness in the future and lead many of the industries that will take us to success. Flat funding rates in federal investments in research, and in many cases declining funding rates over the last decade, have already shown impacts on our scientific talent pipeline, driving away the next generation of leaders and innovators from careers in research. This decline happening while other countries see the clear return on investment in government-sponsored research and are doubling down on their efforts to become global leaders. Indeed, several metrics related to innovation and scientific impact already show that the U.S. is losing ground to countries like China. This trend will only continue at our current level of research investment, and the consequences will impact the American economy as well as our national security. For the U.S. to remain a global leader, we need to lead in innovation, science, and research. American industry leaders recognize the federal government's investment in basic science is critical in driving innovation, productivity, and economic growth. For example, hundreds of business leaders signed the Innovation Imperative Statement, which was a call to action for federal funding increases in basic scientific research. Thank you again for this opportunity to discuss the importance of federal investments in research. I'd be happy to answer any questions.
Thank you all for your testimony. I was intrigued, Dr. Keeley, by your sort of compare and contrast to the way industry works versus how we judge science in universities. And tell me again, what was the name of the author of the paper you said that talked about technology keeps scientists honest? Okay.
In a journal called New Atlantis. It's a very good article.
Okay. But I was intrigued by the contrast between how technology keeps scientists honest, because it basically has to work, and the stuff that work is rewarded, and the stuff that doesn't work may sit around. But it's kind of interesting because people on the left will say, well, we'll never get any basic science research, serendipity, and all of these things where, you know, people put some mold in a dish and discover penicillin are never going to happen if it's just industry. But I was thinking of even in my state, we have Corning, who's been, you know, famous for developing practical uses of science. They developed something back in the 1960s called, they call it now Gorilla Glass, but it was a technology for making this glass. They didn't have a use for it for 50 years, but they kept it in their files. They patented it, and now it's the glass on your cell phone. And it's an amazing thing. I think it drives their whole industry. It drives their whole company now, that what they make, the money make off of this. So I think serendipity and things can come from industry as well. But in contrasting that with university, where the reward is not whether your science is necessarily good or produces anything of value to society or economic growth, but whether or not it's published, how many times it's published, and in what journals. I guess my question to you, though, would be, in looking at this contrast, what do you think of the other side's argument that says, well, we won't get basic science research, we won't get serendipity, we won't get all these clever little things that just happen to turn up from being curious if we had science led by technology and industry?
Well, it's a myth that industry doesn't support basic science. Industry is very generous towards basic science. But because of course industry needs basic science, but the real lesson is historical. Despite Dr. Cunningham's statement that the federal government has supported science throughout the history of the Republic, actually as recently as 1940, the federal government was funding only about 20% of American science or R&D. You became the richest country in the world in 1890 under a regime of complete laissez-faire, and you've only got to look at some of the Senate records of the Senate opposition even to taking the money for the Smithsonian Institution, which was opposed by a number of senators, to realize how long the suspicion has been of American funding of science by the federal government. The NSF was created as part of the Truman Doctrine. It was Truman deciding that he was going to forget George Washington's statement of no foreign entanglements. America was now going to get involved with foreign entanglements, which meant he needed defense research to support his defense initiatives. All that happened as a consequence of that was crowding out. What people forget is the phenomenon of crowding out. When the state funds something, the private sector withdraws. And Dr. Cunningham points out that companies like the government funding science, of course they do. Companies are very fond of corporate welfare. Crowding out is the phenomenon that explains why there is no evidence anywhere that the government funding of science has ever stimulated economic growth, or indeed the amount of pure science. Industry cannot survive without pure science, and it funds it very generously.
Senator Peters.
Thank you, Mr. Chairman. Dr. Cunningham, I would like you to expound a little bit on some of the points that you made. And first I want to say that we know the scientific enterprise and the ability to advance scientific knowledge is a complex ecosystem, and it's not mutually exclusive. It's not just private industry. It's not just in academia. It's about the interaction between all of these entities working together and churning the innovation that comes out of the scientific enterprise. And so, in my mind, there's a role for federal research. Certainly, private industry is a big part of it. In fact, most investment in research is done with private industry today. But I'd like you to speak a little bit just from your own experience. Can you provide an example of research that you have done over the many years that you believe just simply would not have been done if it wasn't for a federal investment?
Sure, thank you. So a lot of the work that we've done has been on looking at ways that we can get adolescents and teenagers who are at risk for substance use and opioid misuse to make safer decisions and to be safer after leaving the emergency department. That's not the type of research that typically would be of interest to industry, would have immediate economic gain to industry, is of tremendous help and benefit to the greater public health, and that type of prevention work is critical to our public safety, public health, and eventually, hopefully, into the opioid epidemic that we face.
So it's not something you'd see pharmaceutical companies doing?
That type of prevention work is not done by pharmaceutical companies.
Right. I also know that the University of Michigan, just from my own personal experience, is an incredible engine of economic growth in our state. And I think it's in no part, or no small part, because of the tremendous research that's being done at the University of Michigan, as well as our other research universities that have created great intellectual hubs that spread out throughout the economy, throughout the business sector. So considering your role in the Office of Research, could you provide some examples of basic research at the University of Michigan that you believe has led to some sometimes significant economic growth?
Yes, thank you. Yes, at the University of Michigan is a tremendous, there's tremendous spillover throughout the state. I mean, first of all, I can say As I mentioned, the 444 new interventions last year and the 12 new startup companies in technologies based on our researchers. A new startup happens about every 4 weeks out of the university research alone. Recently, a company, Neurable, was created by University of Michigan scientists who were studying foundational questions around brain waves. They've then gone on to develop a cap that can help you think about making things move just by wearing the cap. That will likely go on to have great economic benefits down the road. That's really in its early stages right now, but came from foundational research and foundational science. I think also the spillover effect in terms of training can't be overlooked. So, for example, a researcher that did foundational work on semiconductors that went on to being part of Samsung screens came out of the University of Michigan, has had big implications for cheaper and more efficient solar cells, which have impacted our economy, also influenced national security. And really importantly to think about is while that researcher was doing that federally funded research, they also trained 27 postdocs, 52 PhD students, many of whom went on to be faculty and leaders, and eventually leaders of companies and leaders of industry. They were trained with this foundational research. That type of spillover effect is really critical. Also, when we talk about benefits to the economy, it's important to think about that type of linear model has been rethought more recently by many scholars in terms of an innovation ecosystem. And really, we don't see it anymore as a linear model of pure science happening at the institutional level that eventually trickles down in a linear way to industry and to the economy. Instead, we really see much more of almost this what we call tire track model, where there's a lot of interaction back and forth, even at early levels, between basic scientists and industry and basic scientists and the public sector. And those inform each other and they train each other. And in the end, we wind up with an innovation ecosystem that is a lot stronger. I think the university, as well as other academics, have also come to see that we can do better in moving this pipeline faster down the road. And some federally funded programs have helped that. For example, the University of Michigan has what's called a CTSA program, a Clinical Translational Science Award program, which is designed specifically to take early stage work and help investigators move it quicker down a pipeline by connecting basic scientists who often can't speak outside of their field because they're very much experts in a particular field with folks who have applied and practice and industry work to be able to have that interaction happen faster and really be synergistic.
Partially in response to criticism from members of Congress about silly-sounding research grants, we heard some examples of those here earlier today. The NSF issued guidance in 2013 to researchers on how to write titles and abstracts in a way that enhances public understanding of scientific research. It encourages researchers to explain the significance of their projects in a non-technical manner. This change may seem insignificant, but I think it really underscores the importance of building connections between the scientific community and the general public, and certainly reminding Americans that scientific innovation and research benefits the whole country in many ways. So I'm curious about the panel's thoughts on what scientists can do to better communicate the importance of their research to the public and dispel some of these misconceptions about silly-sounding research. I'll start with you, Dr. Cunningham, and then I think we'll only have time for Dr. Nosek. If you'd follow up, I'd appreciate it. Dr. Cunningham?
Well, I think we all have a responsibility to communicate our science better. I think although the silly-sounding science to non-scientists may be difficult to understand the ultimate meaning behind, we are responsible for communicating better. There's a number of ways that can happen. Our CDC center that I currently direct takes each of our science publications that comes out and works with communications staff, specifically pairing scientists with non-scientists in that realm to help create one-page sheets that can be easily understood for the public on exactly what it is we're doing and how that might inform our public practice and health. I think that's one manner. There's a number of other programs that are like that at the American Association for the Advancement of Science via its Center for Public Engagement and Technology, a Science Policy Fellows program that is working to engage scientists in communicating that information better to the public.
Thank you. We're going to go to Senator Harris, and I apologize, but we're going to do 5 minutes so we can try to get through everybody because we're getting ready to have to go vote. Senator Harris.
Thank you, Mr. Chairman. Well, I'll tell you, this issue is very personal to me. My mother was a scientist, an endocrinologist, She advised NIH. She did her research at a number of places, but most recently, before her passing, at UC Berkeley. She maintained a lab for years. And in fact, my first job was cleaning pipettes in my mother's lab. I was awful. She fired me. But there you go. And being from California, we take a certain level of pride, perhaps, and please forgive any bravado, but Google's search engine, its foundational tool, came from federally funded research at Stanford. The nicotine patch that has helped millions of people quit smoking came from federally funded research at UCLA. Augmented reality military training from federally funded research at USC. The hepatitis B vaccine from federally funded research at UCSF, and image sensory technology, which is in our cell phones, from federally funded research at Caltech. So I add that list to the list of those discoveries that you, Dr. Cunningham, have outlined. And my question then is, as we recognize all of that, can you also talk a bit about the concern that many of us have that were it not for federally funded research, the research that would be conducted would be motivated by what is profitable and not necessarily what impacts the largest number of people. And in particular, my concern is for cures that we need for rare diseases, as an example. Those diseases that may impact a few number of people. And so the benefit will be to a few number of people and therefore will not necessarily be capable of being marketed and purchased by a lot of people. What can you talk and say about that concern? And I'll use as examples of those kinds of diseases that also impact specific racial or ethnic groups, and that can be anything from lupus to sickle cell to Tay-Sachs. What is your perspective on that?
Yeah, thank you for asking that question. So, it's really important that the research that's funded by the federal government often has a long timeline to showing results. So that shorter timeline, which is really important to industry and to industry-funded studies, is not going to be profitable, as you say, for these rare diseases or for diseases that are prevention-focused or really focused on a greater public good necessarily, but won't show an immediate return on investment. These are the types of long-term investments that we need to make at the federal level. That's the kind of investment that federal research has shown to been able to do, to invest in things that may be curiosity-driven at this time, but might lead to an end result, which is a cure for a rare disease. I like the example of the honeybees, which is a silly-sounding science study that was done by NSF, where scientists were looking into how honeybees found their nectar in a hive and why that would be relevant. And that was funded many, many years ago. Later on, that went on to give the answers to how to do web algorithms for the internet. So the kind of basic science research that might be funded now might be what gives the cure for your rare disease in 15 or 20 years from now. And that's not an investment that anyone could know in the room up front would cure that disease, and is in the greater public good to take care of, looking into that curiosity to understand the basic science.
And you mentioned return on investment. So there are a lot of experts that I've read who talk about every dollar invested in biomedical research funding, for every dollar, the economy gains roughly $2. And it's even greater for certain projects. For example, the United States invested $3.8 billion in the Human Genome Project, which resulted in nearly $1 trillion in economic growth, which, if you do the math on that, is a 178-to-1 return on investment. So these types of federal R&D investments certainly do help support the economy and jobs. In California, 38,000 Californians have benefited from the Genome Project that I've mentioned. Can you explain why the private sector might not be willing to put an investment in biomedical research on projects that the government has funded? So the concern that we have is the nationwide federal funding of NIH alone supports almost 380,000 jobs and generates about $65 billion in economic activity across the United States. I see my time is running short, and we have to take a vote. So perhaps we can talk about that in the continuing conversation. I'll yield to my colleagues.
Senator Langford.
Thank you, and thanks to all of you for being here and being a part of the dialogue on it. As we go through some of the research, I'm not opposed to research, and I'm grateful every time I pick up my cell phone or visit a doctor's office for research in the past. The question is, federally funded research, should the information be transparent and available to everyone else? How quickly does that get out? How does that get out? The diversity of the selection teams, if that ends up being the same team selecting over and over again and directing funds, and then the national benefit of that. And when I get to the national benefit of it, as Senator Peters mentioned, there are times that I look at some studies, as has already been mentioned, studies about people sneezing on a child's food and are they more or less likely to be able to take that. But I can go to other studies that I've had the opportunity to be able to look at. NSF funded a study on the connection between religion and politics in cemeteries in Iceland. NSF also did a study on 500-year-old fish bones to study social structures in Tanzania. There was a study done on senior dating habits, on how likely seniors are to date and what their preferences are in dating. Now, again, senior dating may be fascinating research, but I'm not necessarily assured that it's federally necessary. Match.com may be very interested in that, and lots of other folks may, as a way to be able to partner up seniors, but is that a national priority? So the questions that I have circle around how we're doing selections of this, who's doing the selection of the funding, and what is fundamental research, and what really should be applied research. And is the federal government really focusing on fundamental research? So my first question really deals with this issue of who's making the decision on these grants come. And quick comment on it, then I want to open this up. I've talked to researchers at universities that say, I write for the exact same research, I write it one way to apply to NIH, I write it another way to try to get a grant from NSF, and I really don't care where I get the funding from, but I write the grant in a way that they want me to write it, trying to figure out who's going to be able to give me the dollars for it. And then I'll target my research based on whoever will give me the dollars for it. That to me is a red flag. I understand if you get an NIH grant, you have to tell NSF that I have it, but if you're applying for both simultaneously, they don't know what the other one is getting, and I've gone back to be able to verify that. So let's start with the basics. The decision of how a grant is done, these decision-making boards, is there diversity in the boards? Do those boards transition and change over, or is it basically the same people doing approvals consistently? And then what follow-up happens from there? So anybody can take that if they choose to.
Thank you, Senator Langford, for the question. I can't speak to the details of how reviews happen across the various agencies, except for having been myself on both sides of it, having been a reviewer of grants and having been a submitter of grants. And in the context of that experience, agreeing to be a reviewer of a grant, the first step that I go through is to assess from the initial information that they provide whether I have the qualifications to review it at all. And if I were to make a wild guess, I'd say if I were to look at the breadth of NSF-funded grants, probably 90% of them, I wouldn't feel like I had the competence to review myself. And so there's just too much information that is depth information that I don't have in insight for how it is to evaluate that. The second challenge, I think, of the points that you were mentioning relating to how the grants are characterized, and Senator Paul mentioned this as well, I think is a critical one, which is it's easy to see the title of a grant as indicating something absurd, like scientists wanted to study shrimp on a treadmill. You know, what were they thinking in deciding that that was a reasonable research question? The challenge, and I think this is one, I think Dr. Cunningham was correct, is the translation challenge that researchers need to do better at, which is it starts with a theoretical question, an interest of principles. How is it that this particular thing works? And I don't know this shrimp example, but I imagine, just guessing, that it was researchers interested in biomechanics. How is it that biomechanics work in some way? And so they had to come up with, how is it that we test it? How do we operationalize that theoretical question into something that's meaningful to test? And it's the operationalization that's often very apparent and very easy to sort of misunderstand as something silly when it's actually testing something deeper. And that deeper question, the theoretical question, I think researchers need to do a much better job of surfacing as the point of the research so that taxpayers can recognize what the value is.
Right, let me make just a quick comment on this, because I'd love to be able to work in a bipartisan way on this, because I think there's a lot of common agreement on it. Science that's paid for by the federal tax dollars should not be then retained by individuals saying, I'm going to hang on to that. If it was done for the public good, it needs to be publicly available as that science. I think that should be a given. That's not always so at this point. There should be diverse selection teams. If it's the same team selecting the same type, they're going to select the same type of research year after year from the same universities year after year. And if you're one of those universities that benefits from that, you'll always want that to stay status quo. But I think it's not how we get diverse backgrounds on it. And I think we need to make sure it actually has national benefit in its fundamental research, not something that doesn't have national benefit. I think we can find agreement on that, and I'd love to be able to finish that work.
Quick comment. I mean, there's a possibility these studies are not silly and we need better titles so they're not silly, or there's a possibility they're silly. You know, tasting wine, studying alcoholism and tasting wine, silly. Sneezing on food, should we eat it? Silly. It's not the problem with the title or translating good research into a bad title. Maybe the research shouldn't be done. Senator Hassan.
Thank you very much, Mr. Chair, and to our ranking member as well, and thank you, witnesses, for being here. And I apologize because as soon as I get done asking questions, I think we're all going to bolt, and I apologize for that, but we've got to vote. So, look, and I'll just make a quick comment as well. I still remember one of the early public health challenges I dealt with in public life was the onset of EEE, which is a kind of mosquito-borne illness that is rare but happened to occur in my portion of my state of New Hampshire when I was in the state Senate. And there wasn't any private sector interest in developing a vaccination for EEE because it is so rare that the investment in doing it wouldn't be paid back in any way given the rarity of the disease. And so I watched constituents deeply debilitated by this disease and who lost their lives to this disease, in part because there was no economic incentive for developing the kind of treatment. So I think it's really important to remember the public purpose. I did, to that point, want to ask Dr. Cunningham a question based on your testimony. You discussed your personal experiences dealing with the heroin, fentanyl, and opioid crisis, an epidemic which is having a truly devastating impact on communities in New Hampshire and across the country. I'd like to highlight the important connection you made in your testimony between addressing the epidemic and federally funded research. Another example comes once again from my home state of New Hampshire. In order to fight this epidemic, it's critical that we understand the current trends of the crisis across the United States. The National Drug Early Warning System is an important system that helps us monitor emerging drug trends to enable health experts, researchers, and concerned citizens across the country to respond quickly to potential outbreaks. This surveillance system is supported by grants from the National Institute on Drug Abuse. Last year, the National Drug Early Warning System released a critical report based on research conducted by Dr. Lisa Marsh at Dartmouth, as well as New Hampshire public health experts at HIDA and the State Office of the Chief Medical Examiner. This report brings us closer to understanding the patterns, causes, and effect of heroin, fentanyl, and opioid misuse in our communities. And it's my understanding that NIH and the National Institute on Drug Abuse are expanding their funding for additional research in New Hampshire to continue to help improve our response to this epidemic. Dr. Cunningham, do you agree that this kind of federal funding is critical to help public health researchers such as yourself determine how we can best respond to the ongoing substance misuse crisis?
Yeah, thank you for the question. The federal research is completely critical. We have a horrific epidemic on our hands with opioid and heroin overdose. Before we throw and waste federal dollars at programs that may or may not work, we need to understand which programs are actually going to make a difference and decrease and save lives. And we will do that by rigorous behavioral research being done by NIDA and the CDC and NIAAA that are well-designed, well-reviewed by our peers with very diverse panels of people from all across the country to try to understand how those are going to be the best solutions so that eventually when we then go to implement the solutions into local communities with local values, we know that they'll work and we'll know that those solutions that we're throwing out there won't actually do harm because they haven't been rigorously tested by scientists. Thank you.
Well, thank you very much. And in the interest of getting us to our vote, I'll conclude. Thanks. Thank you again, witnesses.
Thank you. Senator Peters, do you have a statement you'd like to make, or are you? Okay. Well, thanks, everybody, for appearing. I apologize a little bit for the rushed schedule, but we never know when we're going to vote till about 20 minutes before we vote, and we have a series of votes coming up. I think the testimony was good. From my point of view, I would just say that we do have a problem, and we need to admit we have a problem. It's not that we don't have silly research going on. We do have silly research going on. It's not just the title, and cleverly changing the title to obscure the silliness of the project won't make it any less silly. What we need to do is have less silly research so we take our precious dollars that we have and they're spent more wisely. So I think if we look at the way they're approved, I think we ought to consider that you shouldn't get to pick the people approving your money. That makes obvious sense, to me. I can't imagine how anybody would think that the person applying for a grant should get to pick the people on the committee or have any influence on the people on the committee. I also personally think that there should be people on the committee who have nothing to do with that subject, who are well-intentioned, people educated enough to understand a scientific project being explained to them, but that have no dog in that fight. They're not going to have to turn around next week and ask for approval from the same people on these committees. It's this circle back and forth, and I think really we need some people independent. I'd put a taxpayer advocate on the committees. I'd put a scientist who's not involved with that research on the committee. And so there's a lot of things we could do. But the bottom line is what William Proxmire pointed out in the 1970s, the Golden Fleece Awards for this crazy research, sneezing on food, senior dating, gambling in Uganda, just bizarre stuff that everybody agrees the government shouldn't fund. Let's don't say that it's not silly. It is silly. Let's quit doing it and let's fix it, because I'll tell you the danger is if you don't fix it and you're part of the receiving folks in this branch of government, this fourth branch of government, there's going to be a day in which people are going to get mad and there's not going to be any more money. People are going to get mad and finally say enough's enough. So if you like the gravy train, I'd recommend that we fix it so we aren't funding really crummy research. And I think it's still out there. It may be the exception rather than the rule, but there's enough of it that every year we come up with dozens of them. So I would suggest that the scientific community needs to get together and admit we've got a problem and fix it. Thank you all.